Lesson 8.6 Identify Special Quadrilaterals. By the end of today's lesson, we will be able to successfully identify special quadrilaterals. Example 1. Quadrilateral ABCD has both pairs of opposite sides congruent. What types of quadrilaterals meet this condition? Well, there are many possibilities. Parallelogram. Has both pairs of opposite sides congruent, and so does a rectangle. And a rhombus and a square also has both pairs of opposite sides congruent. Well, the difference between this group and this group is that for the parallelogram and the rectangle, they have two pairs of opposite sides congruent, but not necessarily all sides are congruent. But for the rhombus and square, all sides are congruent. Example 2. Quadrilateral JKLM has both pairs of opposite angles congruent. What types of quadrilateral meet this condition? And I would like to say that the parallelogram, the rectangle, the rhombus all meet this condition. So we can go ahead and write parallelogram, rectangle, rhombus, square. Example 3. Relying only on the marked information, give the most specific name for each quadrilateral. Well, for part A, we know that all sides are congruent. So we can only conclude that this figure is a rhombus with 4 congruent sides. We cannot say it's a square because it does not have the right angle symbol. And for the other one, I see that I have 2 adjacent congruent sides, 2 pairs, then this should be a kite. Two pairs of consecutive congruent sides, or adjacent, meaning they're next to each other. Okay, example 4. Is enough information given in the diagram to show that quadrilateral FGHJ is an isosceles trapezoid? Explain. Well, step 1, we need to show that FGHJ is a trapezoid. And that angle G and angle H are supplementary. But angle F and angle G are not. So FG is parallel to HJ, but FJ is not parallel to GH. So we have to show that FG is parallel to JH and FJ and GH are not. So by definition, FGHJ is a trapezoid. Step 2, we need to show that trapezoid FGHJ is isosceles. Angle F and angle G are a pair of congruent base angles. So FGHJ is an isosceles trapezoid. By theorem 8.15. Example 5. Is enough information given in the diagram to show that the quadrilateral BCDE is a rectangle? Explain. Well, this is actually a pretty quick one here, since the total angle measure of the interior angles is 360 degrees, and then we have 3 right angles already, so angle D must also equal to 90 degrees. And according to the rectangle corollary, you need 4 right angles in order to be a rectangle. So yes.